So we have found out how to calculate z-scores from the formula, and we're going to take a step back and think about the larger picture of z-scores in general. So what happens with z-scores is they become a very important topic for us, particularly from chapter 7 onward. So why is that? Well, it's because the z-scores themselves form a distribution, which is called the standard normal distribution or the z-distribution, the z-curve. And it looks like this, right? It's a bell-shaped curve. It has a mean in the center of 0 and a standard deviation sigma equals 1. Now those are population values because hypothetically speaking, you have all of the z's, right? And since it's a z-curve, it will automatically follow this. So the z-scores will form this kind of distribution under certain conditions that you'll learn about in chapter 7 and chapter 8. Suffice to say up till then that z-scores form this kind of curve, and you'll notice having a z-score that's high, like 3, is very rare. That's why the curve is so low down there. Having a z-score of 1 is not as rare. That's why the curve is up higher than there. And we'll talk more about this again, chapter 7, chapter 8, and so on. So the markers on the horizontal axis, you can see down here, there's 0, there's 1, there's 2, and 3. Technically the curve keeps going from there, but it's rare to have anybody past 3. Very rare, in fact. All right, now also keep in mind that this means that somebody who has a z-score of 0, that means that they're at the mean. Their score was equal to the mean's score, and that's why when you substitute it into the formula, if you took the score minus the mean and divided by the standard deviation, you just get 0 because they were at the mean. Now, the magnitude of a z-score is the distance away from 0. It's the absolute value of z, if you will. It's how far your score is from 0. So, for example, 1 over here on the right, that has a magnitude of 1. But negative 1 over here on the left also has a magnitude of 1 because negative 1 is 1 away from 0. Distance is always positive, right? Essentially, it's the absolute value. Okay, so we're going to take a moment and think about what this would look like graphically. And again, a lot of this is going to come back for us both in the next couple pages after this problem, but also later on in chapter 7, chapter 8, chapter 9, and so on. Okay, so we're going to match each letter, appropriate letter, match each mark with its appropriate letter from the graph. Sorry about that, typo. So match each z-score. How about that? Z-score with its appropriate letter from the graph, excuse me. Okay, well, let's start with the beginning. So at z equals 0, 0 would be the center of the graph because if you have a z-score of 0, it means that you're at the mean. So when you look at this graph down here, you can see that E, right there in the middle, has got to be that. And then think about where a standard deviation falls. We learned in section 3.2 that standard deviations fall at about the inflection point, which is a little bit above the halfway point between the highest and the lowest part of the graph. So figure about there is about halfway where my marker is. I don't know if you can see that, but a little bit above it is 1. And then that same distance has to be matched to make 2, to make 3, and so on. So what I'm going to do is I'm going to copy and paste in a graph that has those tick marks laid out for us. 1 second. There we go. So you can see it a little bit better. So you can see that that E letter is right on the center. And you can see where I have this little blue mark right here, that's the first standard deviation, just FYI. And notice how those standard deviation marks are exactly the same distance all the way along the horizontal axis. They're getting covered up for good reason a little bit down here on the bottom, so it's a little bit easier to see them on the top. Okay, so that means that this has to be letter E for the center. Now, -2 would be 2 standard deviations below. So when you look at E and you think, okay, well, 1 standard deviation would be to the inflection point, which is about where the letter C is, to be honest. And then you need to go that exact same distance out once more, which means letter B is at about -2. Now 0.75, all right, 0.75 is on the positive side, so we're going to be looking at the ones over on the right. You have to be past 0 but not quite to 1. Now that leaves us 2 options, F and G. Well, F isn't going to work because, well, let's put it this way. Somewhere between F and G is about the halfway spot. That'll be about 0.5. 0.75 is farther away than that. And that means that it has to be G because G is closer to 1, if you will, and farther away from E than F is. F is actually closer to about 0.33 if I was guessing at it. So G is the one that is 0.75 away. It's not quite to 1, but it's getting there. Remember that the first standard deviation falls at that inflection point, which is a little bit above the halfway spot between the highest and the lowest part of the curves. Roughly, that's how you can eyeball it. Technically, it means that the second derivative is equal to 0 and some other stuff from calculus, but we're not doing that. All right, so two z-scores with the same magnitude. Well, magnitude is how far away from the center they are, right? So what we're looking for are two scores that would be the same distance away. Well, obviously this is going to be one on the right and one on the left. Otherwise, there'd be two scores on top of each other, like both on the right or both on the left, and we don't have that. So I think it's going to be somewhere between the C, D, E, F, G part. Remember, E is your center point. So what you're looking for is letters that are equal distance away from that. So F and D won't work because F is obviously closer to E than D is. G, however, G is about 0.75. If you look at C, C is much farther away from the E than D is. So the answer is actually D and G. They're both about 0.75 away. It's just that D is on the low side and G is on the high side. But they're both about 0.75, roughly. All right, now let's see here. Which one has the absolute value of Z being the largest? Okay, that would mean that the point, the z-score point, is as farthest away from the center. Well, there's only two options there, A and H. Okay, but if you look at A is beyond 2 or 3 standard deviations away. You can see the little 3 standard deviation mark right there, right? And remember, you can, even though the original graph didn't have those standard deviation marks, you could figure out where they are roughly by looking for the inflection point and then making that equal distance, equal spacing all the way along the graph. So A is further out. H is a little bit closer. H is about 2.7 away, say. A is about 3.1 away. So A is the answer. By the way, one other thing. Let's say you didn't put the tick marks in. How could you tell? Well, if you look at H, it has a little bit of a white gap right there. See that white region to the right? That means there's a little bit more tail showing over here on H than there is on A, where it's just black line to the left. That's another sign that A is further out than H is, even if you didn't put the little tick marks in for the standard deviation markers, although that helps. All right, now which one besides 0 would have the absolute value of Z be the smallest? Right, because obviously E is the smallest because the absolute value of E is going to be 0. But the next one that's closest to that is actually going to be F, right? Because F is the closest to that center line. All right, so hopefully that helps you get a sense of where z-scores fall on the standard normal distribution. And like I was saying earlier, that's going to come back a lot in chapter 7, 8, 9, and so on. You'll have z-scores given to you of like 0.75, and you'll have to appropriately place them on the curve, right? Which means, for example, if it was 0.75, you'll have to know that it should be before the inflection point, things like that. Or by the same token, if it's -2, you should know that that's kind of far out in the tail, but not super far out like A is, right? B is the one that's -2. A is actually past -3. All right, I hope that helps. I'll see you back here for more tutorial videos.